Now we will see finding values to be loaded into the timer. So assuming that we know the amount of time delay. So for example, if we want 5 seconds of delay, 5 milliseconds of delay, 10 milliseconds of delay, so that is the time delay we know. And if we know the time delay, so what values we have to load into the timer register? It can be in TH and TL registers. Okay, so before that we'll see one small program. It is for mode 1 programming. Clear port 2.3, move tmod comma hash 01h, mode 1 and timer 0, TL naught comma hash 00h, th naught comma 0EEH. Okay, so this we have already loaded the values. So this we had to calculate how you got this 00 and EE for some milliseconds. For some seconds this is the initial value. For think that for 5 milliseconds it is EE00. Okay, for 10 milliseconds it can be different. For 20 milliseconds it is different. Okay, so this we had to calculate. Now set bit P 2.3, start the timer, keep on checking whether the overflow flag is set or not. Clear if it is set, come out of the loop, then clear this P 2.3, stop the timer, clear that flag, yes, jump here again it will go back here, again it will load the values, again it will start the timer, keep on checking, so we will get the pulses here. So how we will do it? Steps. So first divide the desired time delay. So now we know that the time delay we will be knowing. Okay, so we had to divide by 1.085 microsecond. This is just an assumption for 11.0592 megahertz of crystal frequency. So we got these clock pulses. Okay, so for example in question they might ask 22 megahertz. It might be 0.546 microseconds. So now for our sake, we are considering that external frequency is equal to 11.0592 megahertz. For that, we calculated 1/12 of 11.0592 megahertz is 1.085 microseconds. Now you have to perform 65536 minus n. Okay, what is n? N will be the whatever result we got here. We will divide the time delay by 1.05 microseconds, whatever value we get. So that value we had to subtract by 65536. So whatever result you got it here, you have to convert that into hexa values. So whatever hexa values will get, that will be, consider that if it is YY and XX, so this is the initial value to be loaded into TL and TH. Okay. So now we'll see one question. Assume the external frequency of 11.0592 megahertz. What value do we need to load into the timer's register? Now this is what we have to find it. So we have to find what value to be loaded into timer registers. If we want to have the time delay of 5 milliseconds, now we know we need 5 milliseconds of delay. For 5 milliseconds of delay, what is the initial value to be loaded into the timers? Show the program for timer 0 to create a pulse width of 5 milliseconds on port 2.3. So whatever program we have seen, that is a program. Now how initial value will get? So what is the given? Given is what? External frequency is 11.0592 megahertz. Time delay is what? 5 milliseconds. And initial value we don't know. Okay. So what was the first step? First step is 5 milliseconds. Desired time delay divided by 1.085 microseconds. I am repeating again. This might change based on the question. Since it is 11.0592 megahertz, 1.085 microseconds. For 22 megahertz, it might be 0.546 microseconds. Okay, so if we divide this, we'll get 4608 clocks. Next step is what? You have to subtract that by 65536. Now we'll get 60928 clocks. Okay, now this is the decimal value. Convert that into hexadecimal value. So this is the hexadecimal value to be loaded into TL and TH. So this is the lower byte, this is the higher byte. TL equal to 00H, TH equal to EEZ. For 5 milliseconds of delay, you have to count from EE00 to FFFF. If you count from EE00 till FFFF, then it rolls back, then you will have the overflow flag. If it is counting from EE00 to FFFF, it is giving you 5 milliseconds of delay. Okay, so initially P2.3, okay, it is setting, it will count from EE00, it will go to FF, so then again it will stop the timer, so this will give you 5 milliseconds. Again S jump here, Again it is sjump here. Again it is loading EE00H. Again it is counting. Again it is starting the timer. Again it is starting the timer. It will stop here. Stop the timer here. Again it is 5 milliseconds. Again it is loading. Again it is loading. 5 milliseconds. 5 milliseconds of delay. So this is how we are going to calculate the initial value of the timers. Thank you.